Okay, I want to do some practice problems here real quick before I let you loose on some that you can do on your own. So let's take a couple of these. I found some multiple choice questions. It seems like a lot of people need some practice with multiple choice, looking at the way the multiple choice scores are on the test. So thought I'd give you some practice with that too while we're doing these problems. Okay, so take a look at problem 1 here. Using a larger sample will make. All right, now you got to think about it. A larger sample size means what's happening? Means n is going up, right? As n goes up, the statistic gets better in estimating the population parameter it's trying to estimate, right? So if we look at n going up, what's going to happen to the confidence interval if the statistic we're using to estimate gets better? If our confidence interval before was this wide, with the statistic being in the middle, if we have a bigger sample size, the standard deviation of this distribution of x bar is skinnier now, isn't it? If it's skinnier, you don't have to have as wide of a confidence interval. And so the answer to this is going to be B. Okay, just that basic relationship between sample size and the size of the confidence interval. That's all we need. Okay, so let's go ahead and take a look then at question 2. Okay, and we'll clear that mess off. If standard deviation is larger, confidence interval will be larger, will be smaller, will stay the same, will change, and so on. Okay, well, take a look at the formula. What is the formula for the confidence interval going to be? It's x bar plus or minus the magic z sigma over square root of n. Okay, and this is what controls how wide the confidence interval is. So if standard deviation goes up, this whole fraction is going to go up, and this whole margin of error is going to go up. And if the margin of error goes up, then the confidence interval will be larger. And so that's that answer. Okay, 3 is a fun one. 3 is one I can pretty much guarantee you're going to see on the AP test. So let's take a look at number 3. Let's scroll down to it here. In order to increase the margin of error by a factor of 3, okay, now I'm going to circle a couple things. Increase the margin of error by a factor of 3. Okay, so the margin of error then, if it was like that, it's going to get stretched out 3 times. What do we have to do to the sample size to make this margin of error stretch out by a factor of 3? Okay, take a look at the formula. Again, what determines the size of the margin of error is, again, this formula in the recipe for confidence intervals. Okay, all we're changing here is n. Okay, what do we have to do to this to make it 3 times as big? I'll let you ponder that for a second. Okay, the square root has a lot to do with it here. I could show you the algebra, but let me see if I can just kind of talk you through the logic. If we're going to increase the margin of error, it means our statistic, our x bar, isn't as precise an estimator as it was before. Okay? If it's not as precise, it means the sample size has to go down. So n has to go down in order to increase the width of our confidence interval, or increase the margin of error. Okay, so we already know that this can't be right and this can't be right. Okay, we have to decrease the sample size to make the estimator not as good to open up our confidence interval. So now the question is, do we decrease by a factor of 3 or do we decrease by a factor of 9? Think about that for a sec. And you're right. The answer is decrease by a factor of 9. It's because of this square root. Okay, let me show you. Let's suppose originally our margin of error is this. Okay? Then let's suppose that we decrease our sample size by a factor of 9. Okay? So now what's happened is our margin of error has become this, n over 9. You see, I took my sample size and I divided it by 9. I made it smaller. Okay, now what ends up happening if you follow the algebra, and if you don't get the algebra, I kind of lose you on it, that's okay. That's fine. This is n, and the over 9 comes out as an over 3. Something divided by a fraction means the denominator of that fraction can come up on top. And so we end up with this. And that's 3 z star sigma over square root of n. But see, this is what we had before, right? And it's 3 times as big as it was before. So that's why 3 is equal to d. Okay, and poof, it's gone. Take a look at number 4. Number 4 is just a computation. Okay, now, I'm going to tell you that the calculators can do this for you. I'm not going to tell you how yet, although if you look at it, you might be able to figure it out. Okay? So let's take a look. If the mean of a certain sample is 8, all right, so here's what we know. Mean, x bar is equal to 8. Sample size is equal to 20. Calculate the 95% confidence interval. Okay, so confidence level is 95%. What does our magic z have to be? Okay, how many standard deviations away from the mean are we if we have 95% in the middle? You can look at your formula sheets and find out that this is negative 1.96 to the right, 1.96 to the left, like that. So z star is 1.96. Unfortunately, we got a little bit of a problem. Okay, the confidence interval formula looks like this. We've got x bar, we've got z star, we've got n, but we don't have sigma. So we don't have enough information to tell. And so the answer to 4 is E. Okay, now if I'm going too fast, whoever's got the remote control, go ahead and pause it. Make sure everybody understands this before you move on to the next one. Okay, problem number 6. I skipped 5 because it's, alright, I'm going to skip a couple here because they're not actually where we are yet. So, number 6, sample of 80 students is randomly selected. So n is equal to 80. Their average score on SAT Math is 580. 580. If the standard deviation for all SAT scores is 100, and the scores are normally distributed, what is the 95% confidence interval for this sample? So z star has to be 1.96, and we just plug stuff in. 580 plus or minus the magic z, 1.96, times 100 over square root of 80. And if I plug all that in the calculator, I get, okay, so I took a shortcut. I went ahead and did it instead of letting you watch me do it. There's my margin of error right there. You might be hard to read where you are, but it says 580 plus or minus 21.9135. Okay, so now we can take a look and see which one works for that. 580 minus 21 is about 550 something. Okay, the only one that fits looks like is this one right here, is D. Okay, because 561 is less than 20, less than 580, so it can't be that. So it has to be D. And there's the answer. Okay, I'm not going to do the rest of them on this page because those are actually 2 sample problems and we don't know how to do those yet. So we'll be doing those in a few weeks. So there's some examples for you. And now I've got some problems for you to do. I had to kind of cut and paste this to make it look right, so it might look a little goofy, but problems 12, 13, 14, 15, 16, and 17, those are the ones that you need to do now. Check that out, see how you do with it. Pay particular attention to problem 17. That's one of those, if we have all of this, what sample size do we need to have a certain margin of error? Okay, that's going to be the hardest one of the group, so I want to make sure that you get that right. There's a really good chance that that's going to be on the AP test, a question like that. And it's not that hard to do, so everybody should be getting that one correct, at least. Okay, if you want to work together, that's fine. Just don't make the noise too loud, okay? Keep it kind of quiet. There you go. And I'm going to go see what's on daytime TV now. Probably not much. Talk to you later. Bye.